The topic is finding unit rates in graphs. The essential question is, when given a graph displaying a proportional relationship, can you find the unit rate? So to find the unit rate from a proportional graph, just go y divided by x. Since it's a proportional graph, you should be able to take any y value and divide it by its corresponding x value. Okay? And label it too. So this graph shows a proportional relationship between hours worked and a person's pay. So I know this graph is proportional, not only because it says so, but because it's linear and it passes through the origin. So the first question asks, how much does this person make after working 4 hours? So go ahead and examine the x-axis and the y-axis. So I see that the x-axis portrays hours worked, and then the y-axis portrays the pay in dollars. So if a person's working for 4 hours, I can pinpoint that 4 hours right here, go up to the line and look at its corresponding y value and see that the pay would be $90. If they worked for 32 hours, how much would they get paid? So it says right here there's 32 hours. So I'm going to again look at the x-axis, the independent variable, 32 hours, and go up to the line and see what the corresponding y value, see what the dependent variable says. So your pay would be $720. This last question on the first page says, how much do they make per hour? So I see right there the word per hour implies, hey, you got to find that unit rate. After working 1 hour, how much does that person get paid? And when I'm looking at 1 hour right here, I don't really see it very well on the graph because it's not very certain right there. I can't really take a wild guess. So in cases like this, you can do what you need to do to find that unit rate because it's a proportional graph. So something that really helps is finding out just some of the little points that are on the graph that are at perfect little intersections with the grid behind the graph. So this is 490. This one right here is at 180. And I'm kind of running out of room. Let's go with this one right here, 360. This one's 32,720. And this point right here is at 24,540. Okay, so I just have some points right there that I can totally use to help me find the unit rate. All you got to do, like it says up here, is go y divided by x. Just divide the y value by its corresponding x value and label it. So since this is a proportional graph, I can take any one of those points. And you'll see that I skipped some right here, and I only did that just because I didn't really have much room. You can label them all if you're bored. All right, so I'm going to go ahead and go with, well, I don't know, this one right here. So remember, it's x and y when you're plotting coordinates. And I need to go y divided by x to find unit rate. So the y value is 180, and $180 is how I would label it. And then the x value that corresponds with that dependent variable is 8, so 8 hours. Look, we have money on top, time on bottom, like you've heard in the past. So to find that unit rate, we want 1 in the denominator. Okay, and to go from 8 to 1, we just divided by 8 to simplify this fraction. 180 divided by 8. Whoops. $22.50. Okay, so my statement would be, after working for 1 hour, a person would have made $22.50. Okay, so the next question says, if a person made $450, how many hours did the person work? So I see that they give me this $450. And when you go back up to the graph, the x-axis represents hours worked, the y-axis represents pay in dollars. So when I see $450, I'm going to look at that y-axis and find that $450. So there's $450. I go to its corresponding point on the graph, and I see that they would have had to work 20 hours. Okay. Now you'll see that this graph right here is linear. Any linear graph, you will be able to find the slope, okay? And as this extension right here, I want you to answer this question. What's the slope of this graph? Remember, I want you to choose a point on the left and go to another point on the right, and then simplify that fraction, okay? Because you're going to write it as a fraction. Rise over run. So you want to see how far up you go? So I'm going to go from, let's see, this dot, and I'll go over to, I don't know, right here, this dot. Okay, so I'm going to go up, and look how it's counting. It's going 90, so 90 to 180 was 90. And then from right here is 90 more, right? Wait, hold on. 90 plus 90 is 180. So I went up 180. And remember, m means slope. I'm going to go to the right. Well, we're counting by fours. 4, 8. Because 4 plus 4 is 8. Okay, and I'm going to go ahead and simplify that fraction right there. A number that goes into both 180 and 8 is, I think, 8, right? No, I mean not 8. Okay, let's go 4, evenly. Okay, so divide by 4 to simplify this fraction. 8 divided by 4 is 2. 180 divided by 4 is 45. And I don't think that simplifies any further. And 45 halves does not simplify any further to where you'd have an integer in the numerator and the denominator. So my slope is 45 halves. Or you could have said 188ths. Same thing, but because it simplifies down to the same. Okay, so basically I could go up 45 and go to the right 2, and there'd be a point. Up 45 units, to the right 2, there'd be a point. Up 45 units, to the right 2, and by 2 I mean, see right here, this would be 10, this would be 6. So up 45, to the right 2, and there's the point, okay? And that's the slope. Go ahead and turn the page. This graph shows proportionality between the amount of red and yellow paint to paint Caleb's room a shade of orange. How much yellow paint is needed per gallon of red paint? So I know that this is a proportional graph not only because it tells us, but because it's linear and it passes through the origin. When a graph is linear and passes through the origin, that would show a proportional relationship between y and x. Okay? So this question right here is kind of implying that we need to find the unit rate, because it says how much yellow paint is needed per gallon of red paint. And one way that we can figure out that value just from the graph, instead of making a table or doing anything like that, is just by using the points within the graph. So what I'm going to do is I'm just going to take a second and I'm just going to just label some of the points in this graph. You don't have to label all of them. I'm just kind of looking for, well, where do I have room to write? Right here, I don't really have room to write, so here I do. That's 9, 6. This point right here is, how are we counting? We're counting by threes. 3, that'd be 6. So this is 15. This has to be 18. And that right there is 12. And then this point right here is 27, 18. Okay, so I just labeled just 3 of them on there, and I'm going to go ahead and find the unit rate to answer this question. To find the unit rate, you just go y divided by x, and you can pick any one of the points on the graph, and since I've already listed these, I'm just going to use one of these 3. I'm going to go ahead and use this one right here. So this was x, this is y. So I want y in the numerator. Y is 12. And what was that right there? Yellow paint. So gallons, yellow. That's abbreviated gallons for yellow paint. And then the x value was 18. And that's gallons of red paint. And to find that unit rate, we want 1 in the denominator. So I'm going to go ahead and just simplify this fraction down with 1 on there in the denominator. Okay, so to go from 18 to 1, we just divided by 18. Sorry, you can't really see that. Divided by 18. So 12 divided by 18. Oh, I got a repeating decimal, so 0.6 repeating. Okay, so something that you ought to know, 0.6 repeating is equivalent to 2/3. So 0.6 gallons yellow. Or you can say 2/3 gallons yellow for every 1 gallon red. Okay. All right, so that's the unit rate. You would need 2/3 gallons of yellow paint per gallon of red paint. Okay, and to just so you know, 2 divided by 3 is equal to 0.666 repeating. Let me show you. 2 divided by 3. There it is. Okay. We need to go ahead and answer this question right here. What's the slope of this graph? You see that it's linear, so you can definitely find the slope of any graph that's a straight line. So go ahead and pick a point and then get to the other point. So pick a point closer to the left, and let's go to, I don't know, this point right here. It doesn't matter. You can do the one right next to it. That might be easiest. But I want to show you that it'll simplify down to the slope, okay? So slope is m. That's how they represent it in math. So we're going to go rise over run. So we're going to see how much we rise. Look, it's counting by 2s. So 2, 4, 6 goes on the top. That's the rise. And the bottom looks like it's counting by 3s. So we were here. So 3, 6, 9. Okay, and we can go ahead and simplify that fraction. Let's go ahead and divide by 2. No, we can't divide by 2 because 9 divided by 2 would give us a decimal number. So let's go ahead and divide by 3. 3 goes into both equally, and we'll get whole numbers. 6 divided by 3 is 2. 9 divided by 3 is 3. So look, slope is 6/9, so we can say 2/3. So let me go ahead and demonstrate that. So see how it's counting by 2? Up 2 to the right 3, because this would be a 6. Up 2 to the right 3, there's a dot. Up 2 to the right 3, there's a dot. Up 2, because it's counting by 2s, to the right 3, because it's counting by 3s, there's a dot. Okay, so that's the slope. Go ahead and look at the next problem. Nathan sells hamburgers in his restaurant. The graph shows a proportional relationship between his profit and the number of hamburgers sold. How much profit does he earn per hamburger? So we need to figure out how much he's making after he sells like 1 hamburger, okay? So let's go ahead and look at the graph right here. You'll notice that it is discrete. That means that the line or the dots are not connected. And so what I'm going to do is I'm just going to label some of these points that are on this graph. So let's see, it's counting by 1. Yeah, it's just counting by 1. So 2 would be here, 4, 5, 6. So I'm just going to pick one. So right there is 3, 750. This one right here is 7, 1750. Right here, this one is 9, 2250. Okay, so we gotta see how much profit does he earn per hamburger. So let's go ahead and do y divided by x. And let's go ahead and pick this one right here. X and y. So y is $7.50 because that's the money. And x is the number of burgers sold. Okay, that's not the unit rate. Let's go ahead and find that. So we're going to divide by 3, divide by 3. 750 divided by 3. 7 and 50 hundredths divided by 3, $2.50. So let's answer that. He'll make $2.50 per burger sold. Okay? And I'm going to kind of show you something that would have made this a little bit easier. Is if you look at this right here, and I see that there's a 1 right there in the graph. It tells me 1 burger sold costs $2.50. So right there, that point right there, that's the unit. That point displays the unit rate. Because when x is 1 and it's a proportional graph, the corresponding y value is the unit rate. That's a nice little trick if you get it. Okay, how much profit will he make if he sold 20 hamburgers? So 20 hamburgers, oh, that's not right here on the graph. So there's a couple ways you can do it. You can, I guess, extend your graph and then see where it would land, but I don't really have room for that. You can use just unit rate to figure that out. So I know that he makes $2.50 for 1 burger sold, but I want to know if he sold 20 hamburgers. So since the burgers sold is on the denominator, I'm going to put 20 burgers sold and set up an equivalent fraction for that. So to go from 1 to 20 using multiplication or division, we had to multiply it by 20. And so you have to multiply the numerator by 20. So 2.5 or 2.50 times 20 is 50. So he'd make $50. He'd make $50 in profit for selling 20 burgers. Okay. All right, let's go ahead and I want you to, well, why don't you try and find that slope on your own, okay? So I don't care which 2 points you use. You should use 2 different ones than me to see if you get it right, okay? I'm going to try to make it easier myself. I'm going to go from here to here. So I'm going to go up, because it's counted by 250, up 2.5 to the right 1. So my slope is equal to 2.5 over 1, like that. Now let's say you chose this dot and you decided to go to this dot. Let's see what we got here. So it's counting by 250, so we went up 250 plus 250, that's 5, so we went up 5. And we go to the right, it's counting by ones, 1, 2. So if you're like, those don't equal each other, let's go ahead and let's just divide this by 2 and this by 2. 5 divided by 2 is 2.5. 2 divided by 2 is 1. So see how it'll simplify down to the exact same slope? Okay. Now the summary. Why do you think number 2 shows a solid line? When it's a solid line, it's continuous. So what I mean by that, why do you think this was like solid like that? Versus number 3, which shows a dotted line. And a dotted line is discrete. Okay? So how come this right here, this graph shows a solid line where all the points are connected, whereas this one down here only shows just dots? We know they're both proportional, so that has nothing to do with it. I just want to know, why is that solid? Why do you think that right there is dotted? Continuous versus discrete. How come? Number 4 says, in this graph, time and distance traveled are proportional. How fast are they traveling per hour? So I know this is a proportional graph because it's linear and it passes through the origin. And this first question is wanting us basically to find the unit rate. How fast are they traveling per hour? Okay. So I would start off probably by just listing some of the ordered pairs that compose this line over here. And it doesn't matter which ones you choose. So pick whichever ones you want. So that's x, it's 30. When X is 30, Y is 1,350. Let's try this one right here. This point is 54, comma, 2,430. Okay, and let's do one more. Well, see this one, I don't exactly know what that is. It's probably in between there, but I can't really tell, so I want to be certain. So I'm going to find this one right here. That's at 18, comma, 810. Okay, all right, so we got to figure out how fast they're traveling per hour. And I'm just going to go ahead and pick this one right here. Y divided by X. So that one's X, that's Y. So Y divided by X to find unit rate. 1,350, that's Y, so that's miles. Divided by X is 54, oh, just kidding, 30. I lost my way. Remember, it's got to correspond. So my mistake, sorry about that. 30 hours. So after 30 hours, they went 1,350 miles. Okay, so to find the unit rate, 1 hour. So we're going to divide by 30, divide by 30. So we'll take that, divided by 30, 1,350. Divided by 30, 45. So they're going 45 miles per hour. They're traveling 45 miles per hour. Okay, after 100 hours, how far would they have traveled? So let's see that. 100 hours, here's hours. Oh, I don't see 100 right there. So what I can do is I can go ahead and set up, two equivalent fractions right here using that unit rate. Oops, I didn't label that. Okay, 45 miles for 1 hour. So they're traveling 100 hours, so I want the 100 over here in the denominator. And how do we go from 1 to 100 using multiplication or division? Well, it looks like I had to multiply by 100. So I got to take this 45 and also multiply it by 100. And when you go 45 times 100, you get 4,500 miles. So they'd travel 4,500 miles in 100 hours. Okay. So let's go ahead and figure out the slope of this line right here, the slope of this graph. So I don't care what ones, you can pick any ones you want. I'm going to go from this one just to this one. It's probably easiest for me. Oh, no, it's not. I'd probably go, what is this counting by? I'm going to go from this one to this one. Sorry. Okay. Use that in blue. This one to this one. I didn't choose this one because I think that's probably going to be, what is it counting by? 6s? So that'd probably, yeah, that's going to be between 6 and 18. But I'm going to use this one because I want to know for sure. So my slope is rise over run, so I'm going to go up 270 plus 270 is 540. So I went up 540. To the right, let's see, that's 12. Okay, let's go ahead and simplify that. So a number that goes into both 540 and 12, let's start with 4. I think 4 goes into both. Okay, so I'm going to divide by 4, divide by 4. 540 divided by 4 is 135. 12 divided by 4 is 3. Can I go further? Yeah, I can divide both by 3. 135 divided by 3 is equal to 45. 3 divided by 3 is 1. Okay, so right there, this is a slope, this is a slope, or this is a slope. It all works. They all simplify down to 45 over 1. Okay? Number 5. Complete the graph that represents this proportional relationship. You will earn $18 for working 2 hours. So you see it's blank right here. $18 for working 2 hours, so I can kind of start right there. $18 for 2 hours. Here's 2 hours, and you make $18. Okay, so let's go ahead and complete this, but I think it would really help if we found the unit rate real quick. And all we need to do is just use that 1 point right there, because I know it's a proportional relationship. So y divided by x, and y is $18 for 2 hours. So for the unit rate, I want to know how much they make for 1 hour. So I'm going to divide by 2, divide by 2. 18 divided by 2 is $9 per hour. Okay? So if it helps you, you can go ahead and build a table. X stood for hours. Y stood for pay in dollars. All right, so let's see, this is counting by ones. So 1 hour, I would make $9. So 1 hour, so this right here is 9. In 2 hours, I would make 18. In 3 hours, I would make 27. And in 4 hours, all I'm doing is multiplying by that unit rate. And in 5 hours, we would make 45. Okay, let's go ahead and plot those points. 1, 9 right there. 2, 18. 3, 27. 4, 36. 5, 45. And you can kind of continue the pattern right here. You know, it'd be 6, 54. 7, 63. Oops. 8, 72. Okay, let's go ahead and connect those points. I'm going to connect it. I'm not going to keep it discrete because I'm going to connect it, because you could totally work for like half an hour or 3.5 hours. So it's not discrete, this is continuous. And it's proportional because not only does it tell us in the word problem, but we also know that this is linear and it passes through the origin, if I can get my line straight here. Okay. Okay. How much will you earn for working 12 hours? So I see I don't have a 12 right there. I can go ahead and find it like I did up here, but I have a table right here. I can kind of continue the pattern with the table. So you work 12 hours, and you just multiply it by 9. 12 times 9 is 108. Okay, so I count using that. So real quick, let's go ahead and find the slope of this graph and represent slope in math. So let's go from this dot to this dot. Okay, it doesn't matter which two you pick. So I'm going to start here. I'm going to go up. That's what, 9. Up 9 more. That's 18. And then to the right, this is counting by 1. So to the right, 1, 2. Okay, let's go ahead and simplify that slope. Divide by 2, divide by 2. There we go. Okay, you could have also done from here to here. It doesn't matter. It's going to simplify all the way down to the same exact number. All right, in a proportional graph only, now this is just something you should notice. In a proportional graph only, the slope will always simplify to the unit rate. Did you notice that? So see how this graph is proportional. Its slope simplified down to its unit rate. Look, there's the unit rate. Here's another proportional graph. Here's its slope. See how it's simplified down to the unit rate? Look, there's the unit rate. Here's another proportional graph. Here's its slope. And look, it also matches the unit rate. Here's another proportional graph. There's the slope right there. And look, it also matches up with that unit rate. Look, another proportional graph right here. Here's the slope, but it's simplified down to, oh, I didn't simplify it all the way down. where is the unit rate? 22.50 per hour. So I can simplify this down even more. Let's go divide by 2, 22.50 for 1. See how it matched? Okay, turn the page. Number 6 says, create a graph to show this proportional relationship. And we know it's going to be proportional because it tells us. And what I know about proportionality in graphs is it's going to be linear and pass through the origin. So here is the statement. It costs $13.50 for 3 people to enter the fair. What's the unit rate? So I can just kind of use that information that they give me right there and find the unit rate divided by x. So cost on the top in the numerator, and there that's for 3 people. I'm abbreviating people like that. So let's go ahead and find that unit rate. So 3 divided by 3 is 1 person. $13.50 divided by 3 is $4.50. Okay, so it costs $4.50 per person. To enter the fair. Okay, now we've got to complete this right here. So you'll see that's blank. I can start off with this $4.50 per person, but I see that I don't have a 1 right there on this graph that's already provided. But I know I can plot the point 3 and $13.50 because it's 3 people, cost $13.50. Okay. So to figure out the other values, something that could be helpful that we have room for is let's go ahead and just set up a table right here. So x is the independent variable, y is the dependent variable, y is the fee in dollars, because the fee depends on how many people there are. So that's why y is dependent. Independent is the number of people who enter the fair, okay? So like if 0 people enter the fair, there would be no fee for them. All right, so we have, there's 3 people entering the fair, that would be $13.50. So we know that the unit rate that we just discovered over here is $4.50 per person. So we're just multiplying all the x values by $4.50. I just put 4.5, which is the same as $4.50. And let's go with, let's see, 6 and 9. I'm just picking right here what they're going by. 12. We can mix it up a little bit if you want. 15. Let's go. I'm just going to skip one. 21. 27. Okay, I don't have to put every single value on there, okay? And so all we're going to do to find that corresponding y value is multiplying all those x values by the unit rate, because this is a proportional graph. If this graph was not proportional, this wouldn't work, okay? And they'll teach you more about that in 8th grade. Okay, so 6 times $4.50 is 27. 9 times $4.50 is $40.50. 12 times $4.50 is, I think, 54. Yeah, 54. 15 times $4.50 is $67.50. 21 times $4.50 is $94.50. 27 times $4.50 is $121.50. Okay, so let's pop some of those points on there. So we got 0 zeros right there. 627. Let's see, is this 27? Yeah, that'd be 27. This one, we're just counting by $13.50, so I'm adding $13.50 every time. Let's see, 13. Okay, and so on and so forth. All right, so then this would be, we're counting by 3s, 3, 6, 9, 12, etc., etc. So 6, 27, 9, $4.50, 12, 54, oops, that's a really big dot, sorry. 15, 67.50. And then we got 21, 94.50, and 27 is 121.50. So although I skipped these values in the table, you'll see that they would be like right there and right there, okay? So I don't have to have every single value in the table. Oh, I was about to connect these, but it doesn't make sense to connect them. We want to keep them discrete because can you have like 3.5 people enter a fair? No, you are either a whole person or you're just a whole person. So that's why we don't connect them. So we're going to keep this relationship discrete by just not connecting the dots, okay? All right. So the next question for this particular problem says, how much will it cost for 115 people to enter the fair? So here's the number of people. You can see that 115 is not on there. It'd be like way over here. So luckily I have this table and I know this pattern. So I'm going to plot in 115 people, multiply that by 4.5. 115 times 4.5, what's that? It is $517.50. Okay. Another way you can do that besides using the table is by using that unit rate. So it's $4.50 for one person. So if you're looking for 115 people, we would have to multiply by 115. So $4.50 times 115, that also gives you, look, it's kind of like right there, $517.50. It would cost $517.50 for 115 people to go to the fair. Number 7 says, this graph shows a proportional relationship between commission earned by a salesperson and the number of sales she makes. So what I want to talk about real quick is this word commission. Commission, the best way to describe it is if you're a salesperson, some salespeople make commission, and what that means is if they sell a customer a product, that person that sold the product earns maybe a percentage of the amount that was sold. So for example, I can think of like when you go to the mall, some of the stores, sometimes those people, the salespeople in some of the stores are kind of pushy, and that might be like an indicator that they might work on commission. Like if you go into the Buckle, sometimes those people that work at the Buckle, they'll be very, very eager to help you, and sometimes to the point to where it's like really annoying. But they do, I mean, at least when I was younger, they worked on commission. So if they sold you something, they earned a little bit of money. Okay, so that's what commission means. I know car salesmen, they also make commission. So if they sell you a car, they would earn a little bit of money for selling you that car. Okay, so that's what commission is. So this graph shows a proportional relationship between the commission earned by a salesperson and the number of sales she makes. So for example, if this person made 2 sales, they would earn $8 off of those, those sales. And you'll notice that this is also a discrete graph. They're just dots because you can't really have half of a sale. It's either did you make the sale or not. Okay, so that's why it's discrete. We do know it's proportional not only because it says it up here, but we know that this is linear and it's going to pass through the origin if I did connect the dots. Okay, so what's the constant proportionality? That's just a fancy word for unit rate. So let's go ahead and find the unit rate. And you can use any values in this table right here. So I'm just going to kind of list a couple. So I'm going to find a couple that like I know for sure right here. So this is 4,16. This one is 8,32. And I don't care. You could pick either one of those or any one of those on here. I'm just going to go with this one right here. So I need to go y divided by x. So this is y, this is x. And this is x, this is y, x, y. All right. So y is 16. That's $16 for 4 sales. So the unit rate that this girl makes on her commission, so for every sale, she makes $4. Okay, she makes $4 per sale. Okay, so using that value for R, write an equation in the form C equals RS that represents the relationship between the commission earned, C, so that's commission, and the number of sales, S. So this one right here is sales. And this R right there is the unit rate. Using that value for R, so using this value for R, that's the unit rate. Okay, so what I've taught you in the past is you go Y equals unit rate times X. X stood for sales. Y stood for commission earned, or money. Commission earned in dollars. And right here would be the unit rate. So our unit rate was 4. And you'll notice that they have specific criteria that they want for this equation. So remember, C stood for commission. Well, Y stood for commission. So we're just going to write right over that. And then X stood for sales, but in what they wanted S to stand for sales. So we're just going to write over that. Okay? So there's our equation. C equals 4 times S, or you could say 4S equals C. Okay? But they wanted it like that, so this is, I guess, more precise. But these, they're interchangeable because they mean the same thing. Okay, so for your summary, I want you to write down what's the slope in number 7's graph. So here's a graph. What's the slope? If you don't recall how to do slope, look at any of the previous examples where we found slope. Okay? And then also write this. What characteristics does a proportional graph have? Okay, write those down. Have a good day.